To make progress in this question, you have to realize that they gave us the derivative and then some points which lie on the function. These points don't lie on the derivative, they lie on the function. We can find the function by doing the integration of the derivative, and that's exactly what we do. Right, so how do we do this integration? Well, it is a chain rule, and so the brackets, when we integrate, are going to stay exactly the same. And the power on the brackets, because it's integration, we add 1 and it will become 3 on 2. All right, so now we start thinking, if we were differentiating this, what would happen? Well, what's inside the brackets gets differentiated, and it would put a 4 out the front, so we need to get rid of that by putting a 1/4. And the power 3 on 2 would also come down and be put out the front, so we need to remove that by multiplying by 2 on 3, which of course is just the inverse. And the 3 which was out the front, well, it just stays out the front. And don't forget to add your plus c. All right, simplifying, we'll have a half of, in brackets, 4x plus 5 to the power of 3 on 2 plus c. Now they told us 2 points that lie on the curve. One we know is 1, 9. And we can use this to find out what the constant of c is. And we simply put in y is 9 and x is 1. That leaves us to solve this equation where 9 is equal to a half of the square root of 9 to the power of 3 plus c. Right, square root of 9 is 3, raised to the power of 3 is 27, so 9 is a half of 27 plus c. This brings us to c is 9 minus 27 on 2. 18 on 2 minus 27 on 2 leaves c as being negative 9 over 2. Our equation, therefore, is just a half of 4x plus 5 to the power of 3 on 2 minus the 9 on 2. Now, to find a, we know what x is, and a is the y value, so we just put the point into the equation, and we'll have a is a half of 4 times 5 plus 5 to the power of 3 on 2 minus 9 on 2. Well, that whole brackets is the square root of 25 raised to the power of 3, and that turns into 125 on 2 minus 9 on 2, which is 116 on 2. Therefore, a is 58. And we're done.